Welcome to the SWAYAM NPTEL course on mechanical and electrical systems of mining machines. So, this is the last lecture of module 2, that is mechanical systems in uh, HEMM. So, this lecture is all about mechatronics in heavy earth moving machineries. Now, first the concepts that we will be covering in this lecture, we will start first with the mechatronics and robotics example from day to day life. Then we will be going to advancement of mechatronics and robotics in mining industry, where we will be discussing a bit about why this evolvement of robotics is necessary, and then we will be going to the broad areas of application of robotics in mining, that is automatic haulage, fleet management system, automated loading unit, truck interaction, telerobotic rock breaking, and then we will be going to bit of basics of mechatronics and then the components of mechatronics system. Well, when we talk about the mechatronics and robotics in our day to day life, so the first fancy thing that we have seen is the TV remote control. So, many of you might be assuming who are from 90s, you might be thinking of, well, earlier we had a button that would give the signals for the TV to operate at whatsoever channel we want. Now, how is this remote with this, how there is a wireless signal that is controlling the TV? Now, with that, again, that is one form of mechatronics that we may say. However, when we talk about the mechatronics that we see in today's day to day life and in the world of AI, where AI is one of the most interesting topic now and it is on everyone's mouth. So, one of the example that we have seen in COVID period is the robotic vacuum cleaner, which used to be in many of our houses, where this robot itself would be traversing the floor and it would be cleaning the floor with the dirts that would be around. Now, when we talk about the mechatronics and robotics application in mining industry, well, we have studied about dump trucks, where we know that dump truck is one of the most used transport machinery for transportation of material from one point to the other, and there may be various issues. Let's say there may be tire wear and tear issues, or there may be fuel theft issues, or there may be delay due to the irresponsibility of the drivers. Even there may be few accidents due to many unwanted conditions. So it was very much necessary to make this kind of machine autonomous, so which comes under the autonomous hauling system. So it's one of the haul, like dump truck, we call it also as the haul trucks. So making this haulage system was easier, as it is a repetitive process, and it was first made by Modular Mining Systems in 2011, where you can see their systems was installed in one of these Komatsu dump trucks, which is a unmanned surface haul truck. So it is one of the robotic vehicle that is used in surface mining applications. Now, the second example that we can see is for a robotic vehicle in underground mines, like the example of this LHT, or we call it as a scoop tram. So which would be scooping the material and it would be dumping it another point. It is just like a payloader. However, it is used in an underground mines, which we call it as the load haul dumper. Now, how this load haul dumper has been made robotic? So there has been two 6 scanning laser rangefinders, which you can see it is at the front and it is also at the back. There is articulation angle encoders. So these are the scanners that you can see. These are the articulation angle encoders. This is the driver shaft encoder, and there are also onboard cameras. So on this also there are onboard cameras and computing subsystems. So this kind of setup was developed by Atlas Copco in 2009. So this is one of the best example of robotics that has been already established in underground mining. We may not be able to see this application in India, however, in different parts of the world, in various countries, this kind of technology has already been developed. Now, another example of mechatronics and robotics in mining industry is the robotic maritime research vessel, which would move over a tailing pond, and it would do a bathymetric study where it would traverse the complete pond and would generate a profile somewhat like this, which gives us the depth of the pond. Even there are various sensors that are installed which will be able to tell us what is the mineral content of the that we can find at the bottom of this tailing pond. Again, this project was by a company called ClearPath Robotics, and this photo was taken from their work that has been done in 2013. So now many works have been made easier due to the application of mechatronics and robotics in mining industry. It is no more as hazardous or dangerous as we have been perceiving. Well, when we talk about why this evolvement of robotics is necessary, so the first concern is the working environment. So we know that there is a lack of worker. There are many officials or engineers who uh, do not want to go to mining industry or join mining industry just because they are scared of this working environment. However, with the introduction of robotics, it would make the life or the working environment in a mining industry much more safer and cleaner, which will attract best brains to work in this exciting environment. Now there is labor shortage, as I mentioned. Due to this working environment, there is labor shortage, there is concern to health and safety, and there is also that affects the operational efficiency. If a working environment is not safe and is hazardous or dangerous to the labor or the workers who are working in that environment, so it would also reduce the efficiency, leading to losses. Now also the sustainability, which is a very big topic nowadays. So this also plays a vital role why this robotics needs to be introduced in the mining industry, because if such technologies does not take up the mining industry, or we do not move to industry 5.0, there then the sustainability would be a big issue, and the people would not be moving towards contributing to the development of these sectors. Hence the broad area of application of robotics in mining, which has already been done to certain extent and can be more explored, are robotic dosing, which is a repetitive process and it can be handled by robotics, or, or robotic excavation, or robotic haulage. We will be discussing a lot about robotic haulage in this PPT. Then robotic mapping and surveying, which can very well be done by drone technology. Then robotic drilling and explosives handling. Well, when we talk about automated haulage system, so this haulage system is a repetitive process and to which automation can bring significant benefits, particularly with respect to safety. So when we talk about safety, these haul trucks are involved in 42% of accidents and 60% of fatalities in surface mining conditions. Hence, if the haulage system is automated, so this area of productivity, repeatability and reduced maintenance cost would generate a lot benefit. Now some for automated automation haulage, port automation is one of the example which is in a more benign environment. It has shown that maintenance cost of autonomous straddle carrier, in particular, as I was speaking about the tire wear, as I was speaking about the tire wear or the fuel cost, are reduced approximately by one third over their conventional operated counterpart. So, automation in haulage system, in port automation, has proved its potential of being used in mining environment. Now, while we talk about the mining environment, where this automated haulage system should be uh, introduced, so there are certain unique challenges that are present in surface mining conditions which may not be present in other robotics applications. So, what are they? First is the scale. The haul truck carries up to 400 tons of material. So, if anything goes wrong, there will be huge loss of life and property. Again, the mining pit, sometimes due to its depth, are restricted with the GNSS reliability. So, that is how the automated haulage system may get affected due to the depth in the mining pit, where getting signal as well sometimes gets difficult. Now, when we talk about the surface mining conditions, they are constantly changing. They are not like we are just staying at one place and we are working repetitively, but this mining environment is always changing because the bench would be moving, and so are these so are the roads, approach roads and the exit roads also would be changing. So that also limits the installation of fixed infrastructure in such conditions. Now, mixed manual operated and automated fleets of machines, which places strict requirement on safety and integrity, is also one of the major challenge. Again, the other foremost and the topmost challenge that we find in automated haulage system in a surface mining environment is all weather operational requirements. So, in all weather, let's say you see here it is very foggy, so it may not be possible for the sensors to work properly so that the haulage system can move from one location to the other. Let me show you one example of a fleet management system that may be affected due to uh, all weather conditions. Now, here you can see there is a rope shovel which is dumping the material into a haul truck. Now, how is this both shovel and dump truck are automated? So, there is a 3D point cloud view you can see here in this picture, which is generated by a cloud source. Now, it would scan the complete environment and it would generate a picture somewhat like this. Let's say it is a rainy or a foggy environment, so it would restrict the visibility, and the development of this 3D point cloud colored intensity map will not be possible, which which is generally taken carried out by this long range laser scanners which are installed on a mining shovel loading a haul truck. So, it would map the environment and generate this 3D point cloud. Now, this robotics and automation, they are also very much helpful for the self navigation of the vehicles in the work zone and also in the approach or the exit paths. So as you can see here, so how the traffic is managed when there are automated loading unit and truck interaction unit. So how does it happens? Let's say at the face there is a shovel which is working, and it has different zones. One is a work zone, and one is a handover zone, and one is a non-working zone. So you can see there is a shovel which is operating at the face of the bench, and there is one incoming truck which moves from handover zone to the zone where this shovel would be able to load the material into this dump truck, and then it takes a turn in the work zone and it goes out through the outgoing path. So this complete thing is mapped by GNSS technology or laser scanners, which helps in appropriate movement of the machines inside a specific zone. Now when we talk about this GNS technology, there may be multiple approach roads through which the multiple trucks or vehicles would be coming. Now this trucks are also automated. Well, when they are automated, it reduces the it optimizes the fuel cost, it reduces the fuel theft, and while they are traveling to one junction, well, when there are multiple vehicles which are at different speed and approaching a junction, they will be able to control their speed appropriately so that they can avoid any kind of collision. So this is done completely with the help of robotics and automation, where this kind of technology can help in smooth operation of the vehicles and the movement of the vehicles inside a mining environment. Now coming to another example of telerobotic rock breaking. So here you can see there is a rock breaker which is on an elevated platform and onto a grizzly. So here you can see it is a grizzly. Onto a grizzly there are rock bolters which are loaded onto. So this rock breaker would be able to robotically it can break the rocks on the grizzly to a specific size, so that it can pass the grizzly without any human intervention. How this human intervention is uh, avoided? So let's say a mixed reality user interface is developed, where on a platform there is a rock breaker is designed and a grizzly is also designed. So you can see in this picture there are multiple cameras which is looking over to the grizzly. So here is another camera, so which is looking over to the grizzly, and while this camera takes the data, it would form a 3D image of the boulder that is on the grizzly, and by help of signals this robotic breaker can be given instructions to break or give this much of force, and it should attack at this angle, so that this rock boulders would divide into smaller pieces. So this 3D stereo reconstruction of the rocks and a mixed reality user interface can be combined with live video, and the rock breaker can be operated without a human intervention. Now coming to the basics of mechatronics. So what do we understand by mechatronics? Well, we understood, we went through some of these examples where we could see that what are the application of robotics that has already taken place, how with different technologies we can make a vehicle human less, or we can make it unmanned and operate it without any human intervention, how we can increase the efficiency, how we can increase the safety. But what exactly is this mechatronics and how it can be utilized for such purposes? Well, we have understood what a mechanism is, and the electronics component and the details of it you will be learning in the second half of this course, or you may be getting this knowledge from other courses. So when you add up mechanism with electronics, it gives you mechatronics. So what we tell it as the mechatronics. The mechatronics is enhanced mechanics with electronics. Now this mechatronics does not only involve the knowledge of mechanical engineering, but it also involves the knowledge of computer engineering, electrical engineering and controls engineering. Now one of such example is in modern automobile. The mechanical fuel injection systems are now replaced with electronic fuel injection systems. So this replacement has made the automobiles more efficient and less pollutant. Now for such technology, the microelectronics and sensor technology has helped the mechatronic system to achieve a very high level of precision and reliability. So even the employment of reprogrammable microcontrollers or microcomputers helps in adding new functions and capabilities to a product or a system. So what is our day-to-day example? It is our domestic washing machine. Earlier you used to see there was a semi-automatic washing machine, where there was a washing part and there was a spinner part. Now there are washing machines which completely do all the operations till spinning automatically. Now there have been washing machines that have already been developed which are AI enabled. If you, let's say you are somewhere in traveling to 100 kilometers or 200 kilometers away, or you are in a different part of the country, but if you travel to a different part of country, that you may not be using the washing machine, but let's say you are traveling somewhere outside and you want to turn on your washing machine using the AI technology from your mobile phone also, you can activate your washing machine. Again, there are dryer technologies that have come up which has made these domestic washing machines quite intelligent. Now there are also four-wheel passenger automobiles which are equipped with safety installations such as airbag, parking proximity sensors. So you can see there are many vehicles. You can find that of Morris garages as well, and you can also find it of BMW or Audi. So those kind of brand of vehicles, they have parking proximity sensors, they have anti-theft electronic keys, so which are the example of mechatronics only. Now when we talk about the components of mechatronics, so one of the perfect example is the spring force system. So this is one of the easiest problem of mechatronics, where let's say there is a spring that is without any particle. Now there is a mass which is added to the end of the spring. So this gives us certain displacement. Now this the mass is the input and the displacement is the output. So that is given to a spring. Well, when we talk about this force that is coming to the spring and we would like to automate it to a certain level, let's say the force is induced into this spring and it changes over the time, then a system can be devised in a way that it will have a displacement or vibration to a certain level, and that can be automated with getting the output displacement and then feeding it into a microprocessor which would send the signal of the input force to increase or decrease, and so on the process can continue. The same example we can see in a mechanical system. So one of the perfect example is the speed of a vehicle. Now there is a gearbox which is rotating at certain speed, and the power is generated by the engine. Now the engine is generating certain amount of power which is stored in the flywheel. Let's say we want the engine to produce some limited or certain quantified amount of power. So how do we do that? So the mechanical system would give the response to a digital or an analog signal. Let's say it is an analog signal or an analog sensor. So that sensor would convert the analog signal to digital signal with the analog to digital converter, because the microprocessor based control system will not be able to read the signal that is coming from the analog sensor. So it would take the digital signal that is converted by the analog to digital converter, and it would process in the microprocessor, give again the output signal to a digital to analog converter. Let's say it is giving to a digital actuator, so this digital to analog converter is not required in between. It can directly, the microprocessor can directly give it to the digital actuator. However, if it is giving to analog actuator, it has to convert the digital signal to analog signal, which would give the signal to this analog actuator. Again, this analog actuator would send the signal to mechanical system to decrease or increase the generation of the power. So this is one of a classical example of a mechatronics system. Now the same thing we can see if there is a hydraulic piston cylinder system. As we have seen, many of these machines, they are hydraulically controlled. So this hydraulic piston cylinder system would give the signal to a piezoelectric device or a strain gauge about the displacement that is happening or the pressure that is built up inside this piston cylinder arrangement. The strain gauge or the piezoelectric device would send the signal to a signal conditioning device, which will condition the signal to a level that is readable. Then from the signal conditioning device, the signal will go to analog to digital converter. It is necessary because if it is a analog signal, it has to be converted to a digital signal so that the microprocessor can understand. Let's say I am from India and you are from China or some other country where we have a different language. So if I am speaking something and you are not understanding, or if you are speaking something I am not understanding, then the communication will not be effective. So that is why for a microprocessor to understand the signal, it has to be converted to the language it can understand. So there is an analog to digital converter that is required. So the microprocessor would again give back the signal as a digital signal. So this digital signal has to be converted from digital to analog signal because the actuator may be an analog actuator. So that digital signal has to be converted to analog signal using a digital to analog converter, which is received by the actuator, and that would again give the instruction to hydraulic piston cylinder system to actuate it appropriately. Now a perfect example of all this we can also see between the conventional machine tool and the CNC machine tool. So the CNC machine tool is completely there is a microprocessor based controller which handles or automates the movement of the cutting head. However, in a conventional machine tool it has to be operated manually. So the vision of mining industry is to have a teleoperator station 100 to 200 kilometers away from the mining site where they can operate the machines without human intervention, which would not affect their health and which will also not interfere with their safety. So this is the vision that we are looking for, and this is why the course has been designed appropriately, so that you have the knowledge of the mechanical systems and you also have the knowledge of electrical systems and IoT and AIML that you'd be studying in module 3 and 4, which will give you a depth and breadth of what is actually required for the upcoming mining industry. So with this, I end my part of the course. So these are the references that you would have already started following. Thank you so much. See you.